So we've moved on to part B of our rock launched from the surface of the moon problem. And part B asks, what is the initial y direction velocity of the rock? And with this, we are given the diagram of the rock's trajectory that we had before, as well as some initial values, including the maximum height, the initial angle of launch, the acceleration due to gravity on the moon, which we calculated in part A, and the rock's mass. So what we first need to consider is that we're not being asked for the initial velocity of the rock. We are being asked for the initial y direction velocity of the rock, which is important because when we visualize the initial velocity of the rock, we're thinking about a line tangent to the point where the rock is initially launched at, and this vector right here represents that. But we need to consider its components instead. So if this vector here is our initial velocity, we need to split it up into its x and y components. So we have here the initial velocity in the y direction, and as well down here the x direction of our initial velocity. So again, we've taken this initial velocity vector and broken it up into the y direction and x direction components of its magnitude. So how can we go about calculating this y component of the initial velocity? Well, just like last time in part A, we need to consider some equations that we can use to calculate our needed value. And there's actually a whole set of equations that we commonly dub the kinematic equations. So if we just list them off here, we can consider which one we want to use to help solve for this initial y direction velocity. So the first equation would be that the final velocity is equal to the initial velocity plus acceleration times time. And then the second equation is that the final velocity squared is equal to the initial velocity squared plus 2 times acceleration times distance. And then the third and final equation is that the final distance is equal to the initial distance plus the initial velocity times time plus 1/2 of acceleration times time squared. And this is 3 whole equations that we need to consider as ones that we can try to use to calculate our initial velocity, because we can see that initial velocity actually appears in all 3 of these equations. So what we really need to do is we need to consider in all of these equations what variables we do and we do not have already. And as we can see out of this stuff that we're given initially, we can tell that we are not given and we are not being asked for a time value. So these two kinematic equations here on top and bottom that have time as a variable really cannot be used, and even if they could, if we had a way to find time, we really want to try to avoid overcomplicating things right now. So what we can do is we can just eliminate these two kinematic equations from our focus, and we can try to see if this kinematic equation is usable by us. And in the end, if it's not, we can reconsider using one of these two, and we can try to find time if that's really necessary. But for now, let's examine this kinematic equation, and let's go back to purple, and let's rewrite it in terms of the y direction so that we can connect our initial velocity to be in terms of the y direction. So our final velocity in the y direction squared will be equal to the initial velocity in the y direction squared plus 2 times acceleration due to gravity, because we talked about how this is an acceleration value and it's only applicable in the y direction, times distance. And we actually do have this distance, and it would be the maximum height that we were given, the maximum height of the rock's trajectory shown right here from the initial point up until the rock has reached the point where it no longer moves upward and now begins to slowly go back down into a downward arch. So if we just consider this first section of the rock's trajectory, we have this initial velocity in the y direction right here that we are looking for, and the final velocity in the y direction up until this point where you stop moving upward and you start moving downward, and in that instance the final velocity in the y direction must equal 0 meters per second. So if we say that this value is 0, and we're looking for the y direction initial velocity, we have acceleration due to gravity, and we know this maximum height, we really have everything that we need in order to solve for our y direction initial velocity. So we can just plug all of our numbers in here, and let's do this down here where there's some more room. So we know that our final velocity in the y direction is 0, and 0 squared is just 0. Our initial velocity in the y direction we don't know yet, plus 2 times negative 1.62 meters per second squared times our y direction height of 5 meters. And of course, multiplying these numbers out is just going to give us a negative number, and then adding or subtracting a negative number on both sides gives us a positive value. So we can just calculate this real quick and get that 16.2 is going to equal our initial velocity squared, and then all we have to do is square root on both sides, and we get that our initial velocity in the y direction is equal to 4.025 meters per second. And with that, we can move on to part C of our problem.